All right, everybody, this is 4.1, key features of parabolas. All right, so in the last unit, we talked about factoring quadratics. In this unit, we're going to be focusing more on graphing and solving quadratics. So before we get into graphing, it's important to talk about some of the key features of parabolas. And understand that vocabulary so that when we graph and when we solve, then we can be using this vocabulary. All right, so one thing we should notice about quadratics is when we graph them, it makes a parabola shape. It's like a U shape. All right, they can be wider or taller or skinnier, so they can change, but for all types of quadratics, when we graph those, we will have some sort of parabola. All right? All right, so let's get into our key features. So some of these things you've talked about this before, like Y-intercept and X-intercept. So the Y-intercept is where the parabola or any type of equation or line crosses the y-axis. So in this situation, we have a y-intercept of 0, 3. And we're going to write these as ordered pairs. Again, we always do our x and then our y, x comma y, whenever we do our x in our ordered pairs, our points. All right, x-intercepts. So in previous years, when you did like linear equations, we only had one x-intercept. But when we have parabola, it can cross the x-axis 2 times. So in this situation, this example above, we have an x-intercept of -1, 0, and then we also have another at 3, 0. So we have 2 x-intercepts. In class, we talked about how what would our graph look like if we had no x-intercepts? So that would look something like if we had a parabola like that, where it never crosses the x-axis. We also talked about how we could have one x-intercept if it came down and just touched just right on that x-axis and then came back up. Okay, sorry, my parabolas aren't perfect, but I think you get the idea. So we could have 2 x-intercepts, we could have 1 x-intercept, and we could also, oops, totally wrote that totally wrong, 1 x-intercept, and we could have 0 x-intercepts. So it all depends on where that parabola has shifted, if it's up or above the x-axis, if it just barely touches the x-axis, or it can cross 2 times. All right. Next we have the axis of symmetry. So that is this vertical line. On your notes above, it calls it the line of symmetry, but in this class we're going to be saying that it's the axis of symmetry. Symmetry meaning that both sides of that line are symmetric. If we were to fold that parabola over that dotted line, then it would land right on top of each other. All right, so the axis of symmetry is a line. If we want to graph a line, a vertical line, it's always going to be x equals. And then we're just going to say what that x value is. It is at 1, so x equals 1. All right, if you wanted a horizontal line, that would be like y equals 1, which would be something like this. All right, so vertical line is an x equals whatever that value is. All right, next we have the vertex. The vertex is the turning point of the parabola. As you go left to right, this parabola goes down, 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 until it gets to the vertex, and then it starts going back up. So that is what I'm saying when I say it has a turning point. That is that special point, the vertex, and that's going to be very important as we go along. So the vertex here is going to be 1, -4. Okay. Next they ask, what do we have a maximum or a minimum value? So if we look at this example, we have a minimum value here at -4. So, and it's a minimum. So a minimum of -4. If the parabola went like that, we would have a maximum. Okay, it would have maximum value. And you may look at this parabola and say, but could this be a maximum? Could these be maximum values? But that's not the case, because the arrow is telling us that it keeps going forever. It never stops. So it goes all the way to, I guess not all the way, it goes to infinity, which isn't a value at all. Okay? Next we have the direction of opening. Is this parabola opening up, or is it opening down? So in this one, it's opening up. It's like a happy parabola. It's filling up. If it was opening down, it would be so sad. It would be filling down. Okay. All right. So this example was up. All right. So here's just some more examples. You're welcome to pause and give it a try yourself. I'm just going to do what we did in class. So example 1, X-intercepts are right here and right here. So -2, 0 and 4, 0. Our Y-intercept, again where it crosses the Y-axis, here would be 0, 8. Axis of symmetry is the vertical line that cuts the parabola in half, which is going to be x equals 1. We have a vertex, which again is the turning point. It's like the top of your parabola, or here it was the bottom of the parabola. Okay, so here we've got 1, 9. And then do we have a maximum or a minimum? Here it is a max, and its value is 9. So max of 9. Direction of opening here is down. Okay. So I'm just going to write these other ones really quick if you want some more practice. So -4, 0 and 2, 0. Feel free to pause and do this if you'd like. Here we've got 0, -4. Axis of symmetry is x equals -1. Vertex here looks like -1, -4.5. And we have a minimum of -4.5. And the direction is up. For example 3, one thing I want to notice here is, what is the x-intercepts? So it doesn't cross the x-axis, so we would say none. The y-intercept looks like 0, -2.5. Axis of symmetry is x equals -1. Vertex is -1, -2. And then the max here would be -2. Direction opening is down. Okay. So one of the stuff you may, oh, sorry, I missed there. Oh, that's good. Okay. One thing you may notice is that like the axis of symmetry is the same as I got a different color, is the x value for your vertex, and the max or the min is always the y value for your vertex. So that's something that you can kind of look at that too if you need to. That almost looks like clown. Sorry about that. Down. All right. So that is those key features, and we're going to be looking at those a lot as we go along. Okay. Next we have the intervals. So intervals are just like a section. So like for domain is all possible x values of the parabola. Okay, so it's basically where does it start and where does it end. That is going to be our interval. If we want to talk about intervals, we either have parentheses or we have brackets. So parentheses, we use it when they are not included. And we'll talk about that a little bit more. And this is when it is included. It's kind of like the difference between less than or equal to. Okay, if that helps. All right, so domain is all possible x values. So if we look at this, and again, these always have arrows. I got those erased on accident. So all possible x values. So we know these arrows keep going forever. The parabola never ends. So for x values, for the domain, it starts all the way at negative infinity and goes all the way to infinity. Okay? You could plug in any x value and you would get a y value. So for all of these parabolas, the domain is always the same. It goes from negative infinity to infinity. Okay? Here we chose parentheses because infinity isn't a value. Okay, so we can't include that value. We can't include infinity because it's not an actual value, a number. Okay? Range is all possible y values. So again, we start at the bottom and go up. So it starts here at negative infinity and goes all the way up to -2. Somebody's going to come and interrupt me in just 1 second. Okay, so how low does it go? How high does it go? That's the range. Okay, so domain is how far to the left does it go? All the way to the right. How far does it go to the right? And range is bottom to top, lowest to highest. Okay, increasing. So x values where the graph has positive slope. So right here, this would be increasing. And then, let's see, why don't I use a different color? I want to use red. Okay. And then this would be decreasing. All right. So, increasing, we want to write an interval for that. And again, it's all the x values. So basically, increasing is everything to that side of that axis of symmetry. So it would start at negative infinity, and it would go all the way to -1. And then decreasing would be the opposite side. It would go from -1 to infinity. Okay, there's one thing I neglected here. The range, we would include that -2. Okay, nice thing about range, it's kind of special. It's the only one that uses the y-axis, so it goes from the lowest to highest. Everything else uses the x-axis. And also, you will use the bracket, because we'll include that. Nothing else here in this unit is going to use brackets. All right, so I hope I did justice with that. So domain is all x values, all possible x values. Range is all possible y values. Again, scan bottom to top. And then increasing is where we have positive slope. Again, we're going to use the x-axis for that, x values. Okay. And then decreasing is where the slope is going down. One way I kind of think of that is you're like going for a hike, and here we are increasing. When you reach to the top, at this very top, we're not increasing or decreasing. We've reached the summit of that mountain, and we're not increasing or decreasing. But once you start walking away from that summit, you're going away from it. You're getting down, you're getting lower or decreasing its height. Okay, so that's why we use parentheses for increasing and decreasing, because at that -1, it's not increasing or decreasing. Okay, so that's one thing I mentioned here, is that all intervals are done according to the x-axis, except for range. Range is we use the y-axis. All right. So let's see if we can answer some of these questions. So domain, again, is always negative infinity to infinity for this unit. Okay. range is how low and how high. So how low, this goes from negative infinity to 2. And for example 5, it goes from negative 4.5 to infinity. Okay. Again, we include that when we do the range. Increasing is everything left of the axis of symmetry. So it would go from negative infinity to negative 1. And decreasing would go from the right side, so negative 1 to infinity. All right, and then for example 5, again, increasing is going to be the right side this time. So it would go from negative 1 to infinity, and then it would be decreasing from negative infinity to negative 1. And I used a bracket on that. That should be a parenthesis. All right. And Noah, could you come back or just do it next time? Thanks. All right. All right, the last thing we need to talk about is positive, negative, and end behavior. So basically, where in this graph is it positive? Where do we have positive y values? So I think we're using this example. So positive values are going to be here and here. And then negative values will be under the x-axis. Okay? So we just need to write the intervals for that. So positive for this example is 2 parts. So one of them is going to go from negative infinity to negative 4. Okay, and again, here we use parentheses because at negative 4, it's 0. The value here is 0. Like its height is 0, and so it's not positive or negative. Okay, and then the other half is going to go from 2 to infinity. Again, we don't include the 4 or the 2. When we write those, we're going to use a symbol called union to say that those are they're together for the positive. Those are both positive. Okay. For negative, it's going to go from negative 4 to 2. So again, this, if we were to combine the positive and the negative, it should give us the domain. So going from negative infinity to infinity. All right. End behavior is basically what happens in the extremes. So as like x goes to infinity, and we go in the x direction going to infinity, so that goes this way, what direction do the y's go? So here they would go up. These arrows continue to go up and up and up. So as x goes to infinity, comma, y goes to infinity. And as x goes the other direction, so we go to the left, to the negative infinity, okay, y also goes to a positive infinity, just like the other one did. Okay, my arrows lack a lot, but okay, so here's another couple examples for end behavior. So again, as x goes this direction, here y is going to negative infinity. So as x goes to positive infinity, y goes to negative infinity. And as x goes to negative infinity, so as we go this direction, y is going down to negative infinity. Okay, so every time this is going to be the same. You're going to write that every time, and then you just need to decide whether the y's are going to go to negative infinity or positive infinity. So like here's another example. I'm actually just going to copy this. Okay, and then so as x goes this direction, y goes up. So that goes to positive infinity. And as x goes this direction, y still goes up. Okay. So basically, if it's concave down, your y's go to negative infinity. And if it opens up, then the y's go towards a positive infinity. All right, positive and negative end behavior. So here's like positive. For this one, this is positive. For this one, the negative is like that. Here, the negative is like this. So we just need to write those intervals. So positive here is going to go from -2 to 0. And then the negative values are going to go from negative infinity to -2. And then also from 0 to infinity. Okay, for 13, it's positive from negative infinity to 5. And then it goes from 5 to a positive infinity. And the negative interval is just between 5 and, oops, I messed that up, that's 7. 5 to 7. Okay, so here is like the whole shebang. You're going to have, I think, 5 of these on your homework, and then I have a couple review factoring problems because you're going to still need that. We're going to take a break with that, but we'll come back, so I don't want you to forget. All right, so here, x-intercepts. Again, x-intercepts are where it crosses the x-axis. So that would be -2, 0 and 0, 0. The y-intercept is also 0, 0. Axis of symmetry is going to be x equals -1. It's that vertical line that cuts the parabola in half. The vertex is going to be -1, 3. That's right here. It's the turning point. We have a maximum of 3. Domain, again, is always the same, -infinity to infinity. Range is how low and how high. So how low would be -infinity and goes all the way up to 3 and includes that 3. Increasing is positive slope. That goes from -infinity, so that's like this part here, -infinity to -1. Again, we use the x-axis for those. Tempted people will say 3, but it's not 3, it's -1, so here. All right, and then decreasing is the opposite side. It goes from -1 to positive infinity. Positive, let's see, positive is these positive values. So that goes from -2 to 0. And then negative is this and this. So that would go from -infinity until it hits -2. And then it starts again being negative from 0 to infinity. And then end behavior is down. Oh, no, sorry, that was, well, where is that? Direction of opening. Oh, that's not even on this problem. Okay, end behavior is x goes to infinity. So we go this direction. Y is going to -infinity. And as x goes to -infinity, y goes to -infinity. All right, so if you have any questions, let me know. I know lots of students kind of struggle with increasing, decreasing, and behaviors are kind of a tricky one sometimes. But if you have any questions, please let me know. I'd love to help you. All right, we'll see.